This is pretty exciting. Thanks for having me here and allowing me to speak to you for a little bit. Hopefully we'll all kind of be able to learn something pretty neat about Scalaz and how we can use it in our day-to-day. Kind of rough framework of this presentation is we're kind of just going to go through some of my favorite features of Scalaz and just talk about them and show examples of how to use them and what they can do for you. I'm not going to get into too much theory about things like monads or functors or things like that. We're going to kind of ignore that and be pretty hand-wavy about it for the most part. Just as a quick introduction of myself, I'm Greg. I'm at Lucid Software. At Lucid Software, we kind of have two main products. We have Lucid Press and Lucid Chart. Lucid Chart has mobile apps. We have Android, iOS, and a web app for building diagrams and flowcharts, kind of a Microsoft Visio competitor, but web-based. And then Lucid Press is more of like an InDesign competitor, also web-based, more for layouts and pamphlets and publication design. So our technology stack is kind of the important things that we have, at least from my perspective, are these. Obviously we use Scala. We're built on the Play framework for our back end. Our front end is Angular 2 and TypeScript. And then kind of a fun thing that we have is our Android app is actually also written in Scala. I think we're one of the few people doing that. That's been a lot of fun, and that's actually what I've mostly been working on for almost a year now. And so I like Scala a lot, so I decided we should try to do Android and Scala and just kind of see what happens. So far it's been pretty cool. So that's for Lucid Chart. We don't have any mobile press apps quite yet. We use a handful of other technologies as well. Our iOS app is written in Swift. We have some JavaScript floating around. There's some Ruby. We also have a little bit of Java and a Node server as well. Yeah, so that's kind of what Lucid is. Fun place to work. If you've never been to Utah, it's definitely worth it. There's a lot of beautiful scenery out there. But anyway, we'll just go ahead and jump in. So this little line, the subtext here is basically how Scalaz describes itself on their GitHub repo. It's just an extension to core Scala libraries to enable some neat functional programming things. Now, Scalaz can be pretty intimidating. There's a lot there. They end up using a lot of complicated operators. It can be difficult to read if you don't know what you're looking at beforehand. Because of their operators, sometimes it can be difficult to Google as well. And so I just kind of want to demystify some layers of Scalaz and hopefully we can kind of make it a little more approachable today. It is worth pointing out that I think most people by this point have also heard of CATS. That's kind of the main competitor to Scalaz. The scope of CATS isn't quite as broad. We'll cover some things here that CATS doesn't actually provide. As far as like preference, which one I would prefer, I don't have a strong preference. I like CATS because it has a smaller surface area. I think it's a little easier to learn and has really, really good documentation. And so at Lucid, we actually end up using both. We use Scalaz inside any of our Play services, and then our Android app actually uses CATS instead. So take that for what it's worth. So one thing I want to cover real quick. When I was first learning Scalaz, one of the things that just drove me crazy was the imports. In most of the documentation, you see this here, where it just says, do these two imports and you've got everything. And that's true, and that works fine. But sometimes you don't necessarily want everything. I've ran into some ambiguity issues through imports and things like that. And so they also provide kind of an a la carte approach to importing, so you can get the instances for things like option, list, or int without including the whole scope of what Scalaz offers. And so that's kind of nice, and on some of the slides moving forward, I'll include any imports like this that might be useful for things that are to follow. But yeah, you can also get the standard data types are usually under just scalaz.that data type, whether it's like validation or something like that. Okay, so let's jump into kind of how Scalaz enhances the Scala experience. We're going to start with Boolean. So you've got this import. This is going to give you some good syntax around using Booleans. The approach that Scalaz takes kind of blends the concept of Boolean with like option or either. So you can kind of do those two. You kind of get kind of the same patterns that you see in something that's more like a monad, but with a Boolean. Maybe not quite a monad, but some similar APIs. We'll look at this code here. We've got a function that takes an option of an int. We don't really care what the implementation of that is, but what you'll end up seeing a lot of times is you've got some Boolean that decides whether or not you should pass in a sum or a none. And so you have this if limit query, we do sum limit, otherwise none. And then we just pass that into run query. So that can get kind of verbose. So Scalaz provides a simple one-liner where we can just say limit query, which is our Boolean. We can do dot option, and then we pass it the value that we want to be returned if limit query is true. So in this case, that expression that we're passing to run query evaluates to some limit, so sum of 10, and then we can kind of expand on the functionality of Booleans a little bit that way and kind of blend it with options for some kind of neat behavior. So you also see patterns like this. You have an if-else type of thing. So if this expression is true, do this thing, otherwise do something else. So you see in eithers, you see this idea of a fold as well. So Scalaz adds that to Booleans. So if fold is true, we can, let's see, I forget the order that it goes. I might have swapped the order of these, I can't remember right now. But anyway, one of these functions will get called if all is true, and the other one gets called if it's false. So that's kind of a neat thing. It just kind of simplifies it and standardizes on an API that may be familiar to you if you use eithers a lot. So another thing is that Scalaz provides some stuff actually for side effects, which is kind of interesting. It feels a little beyond what you'd expect from a language that's designed for pure functional programming, but it's there, and so we can leverage that as well. So we have some function, say we want to close a door, we want to close a connection to something, whatever it is, we can say when door is open, close it, and this will close the door. And then they have kind of the inverse of that. So we can say unless door is open, close it. So in this case, we would have a no op. So that's kind of neat. This is one of the first things that this whole section on Booleans was kind of one of the first things that introduced me to Scalaz and kind of what it can do and how it can just simplify code and kind of change the way we think about these operations that are really common in Scala. And so the next common feature of Scalaz is with their equal type class. So I'm just going to go through a couple examples here real quick. So this in Scala, can anyone tell me what happens if you try to run this in like your Scala REPL? Yeah, so I heard here, someone said it's false, and then we'll get a warning, right? So that's exactly what happens. It actually compiles, it lets you do this, and you get a warning, and it always returns false. So Scala is pretty good, it detects that and lets you know about it. So you could turn on something like X fatal warnings, and this won't happen. But how about this one? What happens with this case? Yeah, so what's that? Yeah, so in this case, we don't get a warning. It compiles no errors, no warnings, always false, and now we've introduced a dead code into our application. So why does that happen? Does anyone know why? So if we look at the definition, first of all, Scala double equals just calls Java as equals, more or less. And so if we look at those, we notice that we have object in any. So we can always compare with anything. It's always valid to do that as far as the compiler is concerned. But it introduces runtime errors because comparisons of different types probably shouldn't ever evaluate as equivalent. And this is a problem that Martin Odersky knows about, and I believe they've actually done some research, and they may have actually already implemented this in Dotty, kind of the next evolution of Scala. And their approach is actually similar to what Scalaz does, so it's worth learning about it for the future of Scala as well. But so Scalaz introduces this. We get a new operator. We get a triple equals, kind of channeling a little bit of JavaScript here to have different ways to compare things. But an important point of this is that whatever we're comparing with has to be the same type of the thing we're comparing. So both sides of that have to be equal. So if we try to do this, now instead of warnings or always false, we actually get compiler errors. And so we kind of move what was a bug in your program into the compiler. And so we can catch that much sooner and before any users actually experience that. This allows for a lot safer refactoring. One thing that I've seen this used with a lot that's been really valuable for me is there's sometimes we can get strings in places like kind of magic strings when really what we want is like an enumeration, right? There's 3 different strings you could have, and so you have all these comparisons of 2 values, a string and something else, or a string and a string, and you want to change that to an enumeration. Well, if you just change it to an enumeration and you have those values, you can still accidentally compare the enumeration and the string, and it'll compile fine, and you'll have bugs in your program. But if you're using an operator like this, you can completely avoid that, and it becomes much safer to refactor your code. We'd also want to do this for things like our classes, right? We want to represent value equality for a class. And so we can create implicit instances of this equal thing relatively easily with Scalaz. There's kind of a lot of code here. I'm not gonna run through it all. But if we actually already trust the standard double equals operator, we can actually simplify that quite a bit. So case classes already have good value equality, so we can use this equal a method and just give it the type parameter, and now we can use Scalaz's triple equal operator to safely compare 2 of these case classes. And like I said, you have to already trust value equality on whatever you're using to do that, or rather the equals method. Cool. So this next thing is the idea of memo. So Scalaz introduces the memo object. Again, this is another thing that I feel like is it feels like it should be outside the scope of what a functional programming library provides. But I think it's really cool, and I've actually been able to leverage this a few times, and it kind of can simplify things. So the idea of this is that it provides a simple way to memoize functions and allow us to just optimize that way. If you have something that takes the same input relatively frequently, or a small range of input, you don't want to recompute that. So a good example is with a Fibonacci function. Most people have probably implemented this function. Here's a simple, pretty naive approach to it in Scala. There's nothing really fancy here. We're just pattern matching. We're grabbing our 2 base cases, and then we're doing the recursive case on the case inline. When we run this function with these 3 values, 30, 40, and 45, when I ran this a few months ago, it took 7 seconds. That's a pretty long time. Most programs or most applications aren't particularly resilient to that much latency. That's pretty bad. Not that you'd ever write a fib function in your program. You might, but probably not. But still, this has exponential runtime, and it shows. A common approach is to just memoize it. And so we can do something like this, use a mutable map as our cache. We can take the input, if it's not in the cache, compute it and store it in the cache, and then just return whatever's in our cache. So it's pretty straightforward, pretty simple. I think most people are going to come up with that solution, except that Scalaz has actually done this for you as well. It has this idea of a memo object, and we can create a mutable hash map memo that takes an int and returns an int. So we store this in a lazy val because we want to reference it recursively, and we need to specify the type there because of that. But we simply wrap up that same implementation that we had before, the simple naive approach, and we get a memoize function more or less for free as far as the code that you have to write. And so it turns that runtime complexity that was exponential into something linear for this particular algorithm, different gains for different algorithms. But so what ended up happening when I ran this is that it took 0 seconds because SBT doesn't have, it has second precision. So it was kind of cool application. This is actually a common interview question that we give people, is we have them do a kind of modified fib function on the whiteboard and have them talk through this. And so I thought it was kind of neat that Scalaz provides some toolkit for that as well. They also provide a handful of different backing data structures for it. So you can use like an array, or you can use mutable data to back it. The weak hash map, which is kind of interesting, it says that actually it will allow objects to be garbage collected. It doesn't store strong references to them, which is kind of neat. And obviously each of these is going to have different performance characteristics. So like an array memoization thing, and you're going to have linear lookups for any of your cached values. And then a hash map obviously has a constant time lookup. And so it lets you pick the underlying implementation, which I thought was pretty neat. I've used this a handful of times. It just kind of simplifies thinking about caching things when you just need a simple in-memory cache that is not necessarily long-lived beyond the function that you're in or the program that you're in, whatever you need to scope that to. Okay, so let's talk about what Scalaz does for option now. And I should mention, so this is one of the things that Cats doesn't have. Cats also doesn't have the Boolean stuff, but I think it's got pretty much everything else there so far. So we'll talk about option. These imports should start to look familiar. They follow kind of a common pattern. Anything that comes with Scala or Java ends up in kind of that STD namespace. So we've got this function. We want to pass 10. Someone in the Scalaz world decided that was kind of ugly, so they made it so you can actually just do this. 10.sum, so we get kind of some suffix operators, which fine, that's kind of neat, I guess. Sure. Okay. So this problem actually comes up relatively frequently, and I think when people are learning Scala, this will bite them. So fold left, you're basically just iterating over and combining everything into one value. That none parameter right there, that first parameter to fold left, is the value that we're starting with. And so can anyone tell me what happens when I try to compile this code here? It's kind of subtle. It has to do with Scala's type inference. But what ends up happening is, because of the way Scala's type inference works, it sees that none, and it doesn't have anything else to infer the type from in that context, and so it finds the most specific type there, or the least specific type rather, most specific, one of those, and it ends up getting resolved to none.type. And so this doesn't compile, even though none and option of string, they are part of a common hierarchy, right? None is a subtype of every other option, but it doesn't compile because Scala's type inference just isn't capable of understanding what you mean when you say none. Which kind of option did you want there? It just assumes you meant the type of this none object, and so it fails to compile. And as you can see, Scala's definition of none is just a simple object, a case object probably. I haven't looked in a while, but it extends option of nothing, so it's kind of the bottom type for options. So what can we do about this? Scalaz provides a simple function here, just a lowercase none, where you can provide a type parameter, and that actually resolves the type inference problem, and allows us in just a simple statement to specify the full type of what we expect this fold left to return. And so if we look at the definition of that function, it's actually pretty simple. It just is a function that returns none. That's all it is, except you get to specify the types so the compiler learns more about what you mean. A while back I created this slide and was using it. I was really happy with finding this because I needed it a lot. And then a coworker of mine pointed out that Scala already has that. So you can just do option.empty for the exact same thing. Maybe it's less pretty, maybe you like saying none and giving it a type parameter, but whatever, they both do the same thing, and then if you go look at the source code for it, they're implemented identically. There's no magic going on here. It's a pretty standard thing, but yeah, cool. Let's see. All right, so we'll talk about either. Again, should start to, these imports are going to be the same a lot of the time. So this will give us the type class instances for either and then some syntax around using eithers. So when we use eithers in Scala, this kind of thing looks pretty standard. We can do folds where we get, if it's a left, we'll call the first function. If it's a right, we'll call the next function. And so there's just two examples of that there. No magic here. This is just standard Scala. And then again, same kind of thing. We can also use pattern matching. But we start to reach some limits of, well, let's talk about it. So we have this code here. This sometimes works. So it depends on what you're using. So let's see. So at Lucid right now, we use the Play framework. We're on Play 2.5, which is a Scala 2.11 application. And then our Android app is also Scala 2.11 because Android does not support some JDK 8 features. And so we can't actually move to Scala 2.12. And so because of that, this actually won't compile. It complains that map doesn't exist on either. And that's true until I think Scala 2.12.1 or 2.12.2. They actually changed it so that either is right biased. And so this would do the right side. And so in an older Scala, and then, so in older Scala, Scala 2.11, any version of that, you have to do something like this. Which is a little tedious. You basically just have to specify your bias for each instance of the either that you get back. And so you can also say left if you preferred a left biased operation, which sometimes you might. And so way back, Scala Z decided to fix this and introduce their own right biased either, except they named it this. They named it \/ So why they did that? Well, I think it has to do with Scala's, Scala actually allows an infix notation on types. So if you have a binary type, type parameter that takes a class that takes two types, you can use infix notation. So cool, I guess. Now we have so now we have a string or an int, I guess. We get to make that motion whenever we talk about this. Anyway, so there either is right biased. So just like the Scala 2.12 either, we can just do map and we can go through these things and we get out the result that we expect, a right value of 11. So for a while, cats had their own version of either as well, called XOR or XOR or exclusive OR, whatever you want to call it. To me, this kind of highlights one of the core philosophical differences between cats and Scala Z, where cats is like, let's name this something people can read and talk about, and Scala Z's like, let's make it pretty, maybe. So anyway, you can type alias this to something more readable. That's what cats had for a while. They don't anymore. All they do now is they actually will just extend the native Scala either, since Scala 2.12 added these features. So you get kind of the same thing. So cats kind of brings in a Scala 2.12 experience into older versions of Scala, which is really nice. So anyway, this is not fundamentally different from here, right? We have the exact same code. We've just renamed some things. And so, let's see. Okay, so we changed this value to a 10. And so our first function is subtract, right? We're going to do 10 minus 10. We're going to get 0. Then we're going to pass it into the divide. And we're going to get a division by 0 error. Right. So we probably don't want that. We probably don't want to just crash the program on something so predictable, right? We know that divide is susceptible to this, so we can kind of prepare for it and understand what's going on and be able to provide more useful information about it. So we can rewrite our divide function to actually check for it and also return an either. And so this behaves basically like you'd expect, right? We have map and flat map, and we get back, we kind of have our standard kind of monadic pattern where we can just compose these things and move through our chain of operations. So that's kind of nice. We end up with a left because we're trying to divide by 0, and then we end up with a right otherwise. We can, of course, use Scala's for yield for that as well, just like you'd expect. So, okay, let's see. Okay, so Scalaz has this idea of one and. I think this is one of the simpler ways to kind of implement the idea of dependent types in Scala. Basically, you have some sort of collection, and you have at least one element in that collection. So we have a head and then a tail. It looks basically like how you'd implement a list, except our constructor requires a head. Scalaz, I think they may or may not provide these. I know for sure they provide non-empty list, but I don't think they provide some of these other ones. But you can kind of implement this however you want. You could do any kind of collection. You could do a non-empty array, provided you provide your right type classes for the operations. Okay, so we ran into this with this kind of thing. We've got functions that run a query, and then we try to implement this list of values into that, or interpolate a list of values into a query, and then someone accidentally passes an empty string into this, and so we end up getting a runtime error because MySQL's syntax doesn't allow for just open close parentheses and an end clause. And so we get just kind of pointless runtime errors that we could just easily fix by changing our interface to require a non-empty list, and now you can't give it a non-empty list. Obviously the types here wouldn't match, but in the general case you can guarantee that IDs has elements in it, and you can guarantee a safe execution of this query. This bug has caught us countless times, and of course a standard approach is to just wrap it in an if, check to see if it's empty, and return some value, right? Return an empty list or something like that. But I think this is cooler. Make the caller a little more responsible for what they're giving you. You kind of narrow your interface a little bit, and guarantee, make some extra guarantees about the execution of your program. Okay. Let's see, so there's the idea of a validation as well. So this is kind of isomorphic with the idea of an either. Instead of a left and a right, we have a success and failure. So it's kind of a more specific version of an either. An either, we tend to use it in a right biased way, but you don't have to. Well, validation specifies that success is the right side, right? That's just how it works. And so it just has more specific semantics, and either is kind of the general case of this. And so we have functions that return a validation. Scalaz and I think Cats introduced this operator here. We have like bar, at bar. I don't know what that's called, but it lets you combine the results of two validations and apply some function to them. And so in this case, we get a success of those values multiplied. If one of those doesn't pass, we get a failure with a string error message. And then if both of them don't pass, or the other one didn't pass, and then if both don't pass, we get the concatenation of that string, of the two string errors. So one important thing to point out about this is that it doesn't actually short circuit. The way like a for yield or a monad would short circuit and just stop on the first failure, this validation doesn't do that. It actually will run all of them every time. And so that means two things. First, you get all of your validation, you know everything that went wrong, and then there can't be any data dependency between the different validations. You can't chain these to pass data to each other. You have to be able to run them independently. Okay, so the strings were concatenated together here. That's not necessarily very useful in practice. You probably want some stronger data type. One thing that Scalaz provides is this validation nel. That's NEL for non-empty list. And so this is basically, these two things are basically the same type here. So validation nel just kind of makes it simpler to create a non-empty list for your failure case. Because if you have any failure, you have one, right? And then if you have more, you just keep appending to that list. And so it encapsulates the idea of a non-empty list pretty well. As you can see here, that kind of translates into the previous few slides. So instead of ending with a concatenation of strings, we end with a list of two failures instead. This could commonly be used for things like form validation. We want to see all the errors when a user enters invalid data. We don't want to just give them one error, make them enter the next thing, then show them the next error, make them hit submit, show them the next error. We can do it all at once, and we can see what they did wrong, and we can report all of that at once. We don't have to do it one at a time. Okay, so we've got monad transformers here. Yeah, so let's kind of build out this API. We have this thing of getting a user. We probably want to return at least a user, right? Well, what if the user doesn't exist? So let's return an option of a user. Okay, that's great. But now we're blocking the main thread. We want to make sure we do this asynchronously. And so, you know, that's common in Play or Android or whatever environment. That's just kind of a pretty standard thing these days. So we would want to return a future or something else. Anyway, we'll use a future because it's common in Scala. And so pretty good. We're async. We can represent a missing user. And so we can kind of go from there. So using this starts to get a little interesting. We can unpack the future. When that future is complete, we can get access to the user by using our map method. So we can get access to the user that way. And then we have to unpack the user as well to get at their email address. And so we kind of have this nested mapping, but these aren't really composable because future and option are different types. So we can't really do this in like a for yield, for example, and it doesn't flatten out automatically. And so, yeah, so here's our type. We stay on the same type, which is good. We want to keep that consistent. But what if we just want to write something like this? This obviously won't work because in this case, this will fail to compile because user is not a user, it's an option of a user. So we still want to async, and we still want to represent a missing user, but we want to flatten it out. So Scalaz and Cats provides an option T that looks like this. We don't need to go into the details of what this means and kind of how it works, but this is what they provide, and they let you use it like this. You can just wrap up your future of an option, and now you can just call map on it, and you get direct access to the user with all the semantics that you'd expect. If there's a missing user, that user.email code doesn't get run, and you're left with a future of a none. So that's kind of nice. You could change your API so that you just get that automatically. And so this is relatively simple. We gained a line and we had to add a wrapper type. Sure. Okay, so what about when we do it like this? We have this more complicated nesting thing, and so since these are monads, these have map and flat map methods. We can actually just flatten this out into a for yield, and so that's kind of nice. We can operate on all of these asynchronous optional values in a very flat hierarchy. We don't have to go crazy with nesting. We can leverage Scala's for yield syntax and just kind of keep going from there. And so without that, this is kind of the code that we end up with. Does anyone want to guess what the return type is here? It's not good. You end up with something like this, where you have a future of an option of a future, blah, blah, blah. You do get at the date. So if you're just doing stuff for side effects, maybe you would do this. But if you actually need to work with values, this is kind of untenable. You can do some things. You could throw in some like awaits and block in certain spots. That will work. That may not be the best thing for the health of your program, but you could do that. You can use get or else in the options so you can get some sane defaults in there and things like that. Or you could just use an option T and not have to worry about any of that. And we can easily get back our future by just doing a .run on our result. So there's a handful of these. They have option either list. You can, of course, create your own if you're adventurous. And then, so any operations you do on this have to be supported also by the type parameter that you're providing to that first type parameter, or f in this case. And so I'll commonly use this with futures just to keep things async and safe. Okay, let's see. How are we on time? What time does the next one start at? Okay, we got a little bit, I think. All right. So applicative, we saw this already. This is the applicative type class is where that bar at bar comes from. And so it just kind of allows you to combine values. And that's kind of it, to just take two things of a type and combine whatever they're wrapping up. And so we saw it with validation. We can actually also do it with options. So if we have a bunch of some values, we can just combine them in some way in a function. And then if you get none, it's the same thing. You just get back none in this case. It will actually, if these were functions, right, remember, it will actually run all three of them, even though the second one would stop it in the case of like a for yield. In this case, it greedily executes all of them. So we can also do it with lists. We have kind of a product of lists here. Yeah, so we can easily do that. You know, it doesn't really matter what kind of operation we're doing on it. We can multiply those values together. It works with futures as well, which can be really nice, because this allows you to start a bunch of asynchronous operations, and then when they're all done, a bunch of independent asynchronous operations, right? There's no data dependencies between them. And then when they're all done, we can combine them in some way or use those results to do things, to move on with our program. And then, let's see, so futures will throw exceptions, right? And so this preserves that. If one of the futures fail, we'll maintain the whole failure there. I didn't try this with multiple failures. I'm not sure what will happen there. It might just concatenate our messages, not sure. Okay, so then we also have the semigroup type class. So they decided that we needed a new operator to do addition. So we have that, which is kind of cool. We can still add numbers. And we also need a new operator for concatenation. But it's the same operator now, right? So that's kind of neat, I guess. But we can also do it with maps, which is, I think, where it gets kind of interesting. So here we have a map with different keys, right? They don't overlap in any way. So we can merge those and we get a map. This is basically just like concatenating two maps together. But how about this case? We've got a map that they both have the same key. This is actually kind of cool. What ends up happening is the Scalaz and this operator, the semigroup, is able to kind of recursively operate on all of the data in this, and it actually will add those two ones together. And so we can intelligently merge two maps. I think with a normal map, if you tried to concatenate these two together, you'll just get back map A to 1, and that's all you'll have. So this allows us to do maybe crazy-ish things like this, but we can concatenate these deeply nested maps, and that C thing, the two lists, get concatenated together. And so naturally this goes recursively as far as you want. You can kind of keep going with that and keep playing around with it. That was kind of fun. I found in like the real world, this has been really useful for merging things like settings or default values. If the user has provided some part of this, but you want to merge in your defaults, right? Using something like this is useful because you don't want to necessarily erase theirs, but you want to combine them in some meaningful way. Okay, cool. That's these two documents here were kind of my main references. The CATS documentation I've mentioned is really, really good, and I honestly learned more about Scalaz through that than I did through anything in Scalaz's documentation. They have a really good breakdown of a lot of the common type classes and data types that you're going to use with these functional programming libraries. And like I said, there's a ton of overlap. And then this Learning Scalaz is also a really great document that is pretty exhaustive on going through some really useful features in their tool. So thank you. Any questions? Anything? Yep.
I have a question over here.
Yep.
What is your kind of onboarding into so someone who's not been deep into these kind of libraries and they come working on your code base? How do you get them up to speed?
That's a good question. We use these libraries, but they're not in every line of Scala that you're going to touch. And so what ends up usually happening is that as people are getting familiar with our code base, they'll maybe come across one of these things and they'll ask about it. We have a handful of people that already know these things, and so it's just kind of, what you'd expect coming into any code base. If you don't understand something, you ask about it, you learn more about it. For the most part, if you hire smart people, they'll be able to pick this up quickly enough. Some take longer than others, and that's fine. That's kind of it. We don't have a core strategy to it. It's just kind of organically learn these. And in code reviews, if Scalaz will provide some value, it'll come up too. So, yeah.
Given the current state of the cats and Scalaz community, what library would you choose for the future?
So I personally probably prefer cats. So I mentioned that we wrote our Android app in Scala and are using cats there. That was because I decided to do that. I like cats. I think it's smaller surface area, easier to learn, great documentation. They have a Gitter channel that is fantastic. Everyone there is super helpful. I've never had any problems, and the main downsides I've come across with cats is that it's evolving quickly, and the API has changed a lot over time since I've used it, and so trying to stay up to date with that can be a little bit of a challenge, but it's usually pretty well documented moving forward. But we use Scalaz too, and I haven't had any major issues with that either. So, yeah.
And have you had any notable performance problems in production with Scalaz?
No. So, no, we've never had anything that led back to Scalaz or cats. Most of our overhead is like anything, it's I/O, right? We're doing network requests and database reads. All of that stuff has pretty consistently been the worst for our performance more than actual functions that we're calling, especially functions from libraries. These functions are pretty fast. They definitely have some overhead compared to not using them, but it's been minimal in our experience. So. Any others? All right, cool. Thanks, everyone.